Hello and welcome to experimentation from home, but through a video, and I'm doing it. But anyway, this is how I'm going to try and make up for our inability to continue our experiment from school. It'll be interesting to see what is left of it once we get back. But first, I need to put on some safety equipment. Just like that, in my old lab coat from my first school that I taught at. Anyway, what we're going to do is try and replicate this experiment from my home, and I'll share the results with you on a class-by-class basis. For this, I actually have a lot of the materials that I needed. For example, plastic cups, which I'm going to use to replace the Petri dishes, and then I'll cover them up with saran wrap to reduce evaporation. But thankfully I have some and some more. The other thing that I also have, which I'm sure you do too in your homes, is white vinegar. That was the exact type of chemical or compound that we used to create the pH solutions, or the acidic solutions. Vinegar is also known as acetic acid, which is something you'll learn about in chemistry. I also have liquid carbon source and liquid fertilizer, which I got for my aquariums at home, but I'm going to be using a little bit of this to recreate those conditions. And finally, I've got a at-home pH testing kit. What is a limitation about this compared to the testing strips that we used before is, oops, just give me a second. Sorry, that was a really urgent science-related matter. So, here we go. We're gonna check out my new aquarium and find the other couple of materials that we'll need for this. I'm sure that a number of you have been wondering what has happened to the fish in the classroom. Well, the big one in the classroom, that one has been in there for an eternity. But the ones that my Explore classes made, I did want to bring back to my home. And luckily I had this spare 320 liter or 80 gallon aquarium that I made for a completely different purpose, standing by so that I could house them. With that, I've transported a lot of the original plants, all of the substrate or gravel, the wood, the rocks, so that I could establish the bacteria to be able to support all these living things. I also transported a lot of duckweed, which has been growing quite out of control, and this is where I'm gonna get the healthy duckweed samples for the cups. Since I have a bunch of materials and I have nowhere to really go, what I'm going to do is set up a total of 5 different cups, each with the same pH, and I'm going to establish a total of 4 different pHs to test to see how that's going to affect the duckweed growth and reproduction. The challenge again, though, being that the pH test kit tests only a very limited range, and one that does not even address the acidity of the vinegar. But we'll still figure out how the acid pH is going to affect the growth. The 4 different pH solutions that I came up with were neutral, or around 7, which is about what our tap water is. The other solutions were 20%, 5%, and 1% vinegar solutions by diluting them with the tap water as well. Serial dilutions are a useful technique to use in various studies that test a variety of different chemical concentrations or amounts of a chemical in a solution. What that involves is taking a little bit of a stock solution, which is your fullest concentration, and transferring a small amount to a solution of water so that you end up with a known lower concentration. Now with the vinegar solutions, I'm gonna have to be a lot more precise if I want to do cereal dilutions. And so I transferred all of that into a drinking glass that I'm gonna pour back into this measuring cup. And do it each time. So I'm left over with this 1/4 cup of vinegar and water solution, the 20% vinegar solution, and I'm going to add that to a cup of water. Urgent! We gotta do it before it cools off! But I've made a solution that is 20% of the original solution. I have a 5% vinegar solution, which I'm going to distribute between all of these cups. And finally, I'm going to make my 1% vinegar solution by adding 1 more cup of water to, excuse the mess, that final 1/4 cup. By the way, this is the same exact process that homeopathic medicines are made. And now time for the duckweed harvest. Ooh, got some Elodia. And we're just gonna bring it back on over to our cups. And I'm gonna select out 5 healthy ones to put into each cup. And then I'll cover it all with a layer of saran so that I can reduce evaporation. And I'll let you know how the progress goes on a day-to-day basis. You know I'm not going to just put these here and not collect data. So once I finish with covering these with some saran, I'm going to record the number of plants and the number of leaves. In each of the cups I put only 5 plants, but the number of leaves is going to vary, and I want to see if that dependent variable is going to have any importance in this experiment. Stay tuned.